Wait for 1 more minute. So please make sure that you do have parabolas because they are quadratic, right? There's no way you can get anything else than a parabola. Pretty fine. Okay. Yeah. Okay, cool. Christopher, which packet do you need? 2. I think there's a 10, 3. There you go. Yeah, go ahead. Did you get? Yeah. There you go. All right, so that should be good enough. All right, so let's see. The first graph. All right, so for f of x, so it's a sketch. All right, so no need to really be super accurate. I like to have at least the number line or the x-axis so that I can quickly label the zeros. So the 2 zeros, right, and both of them are multiplicity odd. So I have -1 and I have +2, right? The leading coefficient is positive, right? So either know quadratically, right, it rises to both sides, or if you want to go with my way, start from the top right, top right. You always start from the right, you know, for a polynomial, but if it's a positive leading coefficient, you start from the top. So go down, right, past the 2 zeros and come back up. Okay. So like I said, you know, no matter how you draw it, it has to look just like a parabola, right? That's it, right? Now, if you want, you can put the y-axis if you feel more comfortable with it. But that's all you need, right, for the first graph. All right, so the second one, and the reason why I have some space is, you know, I'll do more about the graph. So it'll be g of x. Again, I'll start with, you know, a number line. Now, for g of x, how many zeros do I have? G of x. Well, okay, so you're right. So technically speaking, 2, right? But are they the same? Yes, right? It's a 0 with multiplicity 2. That means it repeats itself, right? But there's only one point you have to draw. It will be -1. But with a negative leading coefficient, the graph should start from the bottom right, come up, yes, and touch the point, then turns around. So it's like a downward opening parabola. Okay. All right, last one. H of x. Let's see what it is. X minus 2 squared. Okay. Now, almost the same as the g of x, right? So there's only one. Oh, you know what? If you want, let me put the y-axis there. So it will be somewhere here. So I have a 0 at 2, and that's a even 0. And the leading coefficient, again, just to remind you that it's positive. That means you're going to start from the top right, come down, right, and bounce off. And if you want, you can have a y-axis there. Okay, so let me pull this down a little bit. Again, before I move on, any questions about sketching those 3 super straightforward polynomial, right? But technically speaking, just quadratic. So now, what's the point of getting their sketches? So now we need to figure it out with their sketches. If we can solve a inequality, or a quadratic inequality, right? So let's say solve for x from the inequality, in this case, will be f of x greater than 0. By f of x, I mean 2 times x plus 1 times x minus 2 greater than 0. I hope that you remember what you did back in the fall. There was a section talking about how to solve polynomial inequalities, right? But things are way much worse than quadratic ones. So now I hope that you see we have the sketch of the function f of x, right? And that f of x is nothing but this algebraic expression, right? This polynomial or a quadratic expression. If you want this guy to be positive, it's the same thing asking what intervals of x so that the graph of f of x will stay above, right? The function value of x of f of x will be positive, means the graph stays above the horizontal axis. So now, what do you say? What are the feasible x values on this number line? So that the function f of x will have a positive value or the graph stays above the horizontal axis. Can you see it from the graph? And I'm sure you can see from these two intervals, which I'm highlighting for you. It will be either to the right of the 2, right, or to the left of -1, right? You see that if you ever go with in between -1 and 2, the graph is literally right below. The graph is below the horizontal axis, meaning that the function value is negative, right? But are we allowed to take exactly these 2 points, -1 and 2, if I want the inequality to be something greater than 0? And you should not take these 2 points, right? And therefore, the solution set for the inequality that reads 2x plus 1 times x minus 2 greater than 0, it will be -infinity to -1, parentheses, union, parentheses, 2, comma, infinity, right? So that's the interval notation for the solution set. And that's how we solve. I mean, even in general, a polynomial inequality, but in this case, it's supposed to be as fast as you finish sketching the polynomial. Not to mention, the polynomial is a lot easier to sketch since it's just quadratic, right? Does it make sense so far? So it might not be exactly what you did back in the fall, because I don't have you in the fall semester, but hopefully something is very similar. Now, just to quickly check, if you do see how we're going to do the inequality based on the graph. So what if I change this problem into f of x less than or equal to 0? So now I say solve for a very similar inequality that takes the same exact left-hand side, but the right-hand side, instead of being positive, I want it to be less than or equal to 0. Can you read off the solution set based on the same graph? What would it be? Inside, right? In between. And now what about that equal sign tells us about whether we pick the endpoints? Make them included, right? Therefore, it will be in between -1 and the 2 and using the brackets, right? Cool. And again, soon you'll see that why I have to emphasize this. Not that I say everyone needs that, to refresh, but just want to make sure that we will quickly get to solving inequalities because we need that for domain of logarithm functions. Anyway, so now the next 2 scenarios, since we already have the graph, I think that it will be a lot easier to figure it out, right? So now the same thing will be asking you to solve for x for from a inequality that goes like g of x. This time I'm gonna go with less than 0. Okay. And by the way, so what I mean by g of x, negative x plus 1 squared less than 0. Okay. So now, what do you think? What should be the solution set? And the graph is right there, touching the x-axis only at one point, -1. But I want this graph to be, or the function to be negative. What do you think it would be? Oof. Oh, Rosalind? Mm-hmm. Yeah, perfect. That's exactly what's going on, right? Now, Rosalind, why don't you tell us why you choose to skip that number, -1? Right. Good. It does not have that equality, right? So that means you have to make sure that you rule out only that point. That means to the left of -1, to the right of -1, fine. Not exactly at -1, right? And that's just a fancy way to skip that number. Okay. Cool. Now, the last case scenario, and again, so let's solve for x from h of x greater than 0, and by h of x I mean x plus 2 squared greater than 0, right? But I guess that you figured out just like you saw in the number 2, right? So I'll just put the work here, and the answer will be obviously -infinity to -2, right? Union -2, comma, positive infinity, because there's only one point. Oh, shoot, did I? All right, there's a sign error. It's positive 2. All right, there's only one point that you should skip. All right. So now we're on the same page on, dealing with inequalities. So I don't have to wave my hand and say, hey, you know this, right? Back in the fall, this is exactly what you should know so far. Now, we actually finished everything, for finding domains, or at least that the question I picked from the question bank. I'm sure that we're good on number 11 and 14, right? Because I said all you have to do when it comes to domain of a log function is to take whatever that's inside a log, right? That I highlighted already in the yellow highlighter. Make sure that it will be positive. But you have to ask yourself, what kind of feasible values you're supposed to take for x? So make sure that this guy is positive. And that set of x values will be the domain, right? And therefore, things are pretty simple in 11 and 14. Even number 12, right? So whether or not you were pretty comfortable with that yesterday, the way I talked about it. But now you should look at, you don't have to. I'm saying that if you somehow find it hard to accept that B is the correct answer, ask yourself, how would I make sure this guy, x minus 7 squared, always stays positive? This isn't asking you what value of x such that the function x minus 7 squared stays above, right? The graph stays above the horizontal axis. And I graphed it, right? I even call it g of x, x minus 7 squared. And I realized that it's a parabola open outwards, touching the 7, right? Only once and bounce off. And therefore, all real numbers except for 7, right? That'll work. Cannot take 7 because, you have a 0 exactly, right, from this guy. But log doesn't take 0, right? Negative, 0, they're bad, right? Only positive numbers. I'm not saying that x has to be positive. I'm saying that whatever x you're supposed to take, we'll have to make sure that the things inside the log is positive. Now, number 13, so that's the only kind of problem. You have to do just a bit more algebra, right, to get to the graphing part if you decide to graph and solve for the inequality. So basically, you're looking at this inequality, right? That's the thing stays in log. But I hope you realize, even just by going back to chapter 3 of this semester, the way to graph polynomial, right, not to mention a parabola, is to look at its zeros, right, and the end behavior. We just did that, right? But you know that finding the zeros from the factor form will be a lot easier, right, than, just guessing or whatever. So you factored it, and you know that 99.9% chance those questions in a question bank, if you do not have the factor form, it might, that it's factorable, right? So do that. And -2, -8 most likely gets you +16. Add this to be -10. And now you see that there are two zeros. One at 2, the other at 8. With a positive leading coefficient, so it's a upward open parabola, intersects the 2 points. Then you want that to be positive, right? Therefore, it's to the left of 2 or to the right of 8, not inclusive. Right? That's all you have to do. Now, of course, sometimes they might not put the union sign. They say or. That's the same thing, right? So either you to the union or the or. Logically, they're interchangeable. All right, so I hope that we're good on the domain questions. I think that based on how people react to those answers from some of the questions here yesterday in this class, I'm pretty confident that you guys are okay with expanding the logs, right? Just keep tracking whatever stuff that's raised to the power, but just be mindful that you might get powers like 1/3 because it's the cube root, right? And things that are kept in the log later might not just be x by itself. Could be x plus 4, right? Because it's x plus 4 that gets the second power. It's 4 minus x gets the 1/3 power, right? One more thing to check is should we have a positive or a negative log? And it depends on whether those logs are accounting for things that are coming from the numerator or denominator in the log in the first place. Okay. Yeah, that's and I think that we did 30. We probably didn't talk about anything else, but again, just in case, say 28. You don't have to do it. I just want to write a few more steps. Make sure that you're looking at something that's easier to see right away. Now, it's e times y, both of them raised to the same power, right? The fourth power, right? 1/4 power. So e y to the 1/4 power. So now if you want, you can bring that power down right away, or if you feel like that, writing it, like distributing 1/4 power. So e gets 1/4. Oops. Right, y gets 1/4. You don't have to do that. There are different ways of doing it. Right. So whichever route you take. So you want to go with this route, then you could bring down that 1/4. You're looking at e y inside the log. But again, you still have to separate it, right? That means you're going to get 1/4 under these log, sorry, I keep saying log, ln e plus ln y. But you notice that ln e is 1, right? Therefore, you have 1/4 hitting the 1 and 1/4 hitting the ln y. But if you went with, the other route, you split the e and the y, right? Both get 1/4 power. That means you're going to look at log e to the 1/4, ln e to the 1/4 plus, right, ln y to the 1/4. And the 1/4 get down, right? So you're looking at the same thing, 1/4 ln e plus 1/4 ln y, and ln e is 1, so you're getting still letter B. Okay. Yeah. Now, of course, if it's in a test or final, so I hope you guys realize if you're desperate somehow, remember that since y could be anything that's not going to cause you any trouble, right? Why don't you take y to be some special numbers just to test it out, right? For example, if you take y to be 4, right? And the reason, we'll take it to be 16, whatever. You have calculator, right? It doesn't make any difference if you take like an ugly number or an easy number. But once you do that, let's say if you take y to be 4, calculate what this guy is. And then, by the way, all 4 options to see whichever that matches, right? And I think that should be good enough. Now, then the condensing process is identical to what we just did, right? But instead of going from a compact log into like a lengthy addition, subtraction of a whole bunch of logs, you go back, right? But I mean, you could go back by simply thinking about which of those options that actually works out, right? For example, if you take like a 34, I don't know if we did that. I think you probably did yesterday. But let's revisit it. All right, so 34. So I see that there are 3 logs. The one deals with m, and n, and a k. That means those are the 3 guys. Later on, it's going to be inside a compact log, right? But I notice there is a negative sign in front of the log that takes the n. That means the n is going to go into the denominator, right? So right off the back, I'm going to rule out the d because n is not in the right place. And I notice the 2 in front of the log sub 8k. So then the 2 should be absorbed, right? Contracted back onto the top of the k. The k has to get a second power, then that k doesn't have the correct power, right? C is out. So now you're looking at either m over k squared n or m k squared over n. So now notice that the k has a positive sign, while the log, right, that has k in it, has a positive sign in front. That means it has to go to the numerator. Okay. So you can go either this way by going through the options, or if you remember that splitting 2 logs into a subtraction or addition, originally you're looking at a log of m and n, right, dividing each other due to the quotient rule, right? Okay, so at least for the quiz, if you feel like doing so, doing that quiz before the end of the class, it will be everything up to question like 35. So there's no equations about exponential logarithms. Tomorrow's test, the same thing, right? So you're not expecting anything beyond, that chapter 4 packet, beyond question number 35 on that chapter 4 packet, okay? And of course, I will spend a bit more time on, solving equations if I were able to get that today, but, not necessarily that I have to rush since tomorrow, not just the exponential logarithms, the ellipse, hyperbola, and parabola. Now, for this class, I think that it's more important for us to revisit some of the problems about those topics, since you're going to see it tomorrow anyway. But that will be also serving as the final review. All right, so I probably don't have the time to come back to, chapter 10 anymore. But, since I already have the final review packet, so why don't you, why don't we look at those questions, right? So let me pull those questions up to the front so I can, so when I organize my work, it will be a little bit easier. All right. Remember what I said? Whatever questions that I demonstrate in class, say for 41, even though it might be super easy, but I still urge you to try, let's say 42, when you get a chance after class, okay? You can watch the recording, see what I do for 41, then go try, 42 right away. or ask me for the work that I do, just to probably organize it as some kind of a final review portfolio. But I do believe so people missing one question yesterday in a quiz is probably not because the ellipse. But I still want to use the ellipse to quickly demonstrate the thinking process. So tomorrow, I think that the timing might still be challenging, or at least I prepare for, the worst case scenario, because 20 questions, again, you have no more than 2 or 3 minutes for each question. Final, you do get a little bit more time. But, the test, if somehow that the second test that was like 5 points average, lower than the first test. So hopefully you're going to get at least 2 more questions right than you normally do. But now the thing is, the average of the class is 8 out of 10, right? That means, I'm not saying that you should get, like 20 out of 20, but aim at least 15, or hopefully the more the better, okay? But 15 is only what? 75%, right? That's still the same as the second test, right? Get 16 out of 20, right? At least. Anyway, now for 41, so we should, of course, quickly write the equation into the standard form, right? By dividing out the 64. So we're looking at 4x minus 2 squared over 64 plus 16x, well, y plus 1 squared over 64 equals 1, right? Then you're going to divide out the 4 and the 16 to make sure you only have the perfect square on the numerator. So that will turn into, let me zoom out just a little bit. It'll be x minus 2 squared over 16 plus y plus 1 squared over 4 equals 1. So when it comes to ellipse, it's almost trivial to find out what A, B, and C are, right? So A is going to be the biggest number. Therefore, you're going to go with the square root of 16 because it's A squared. That'll be 4. B will be the square root of the smaller number. That'll be 2, right? I mean, you may or may not need the C, especially in 41. You don't need the foci. You see that? They didn't even label it. But just to be consistent, if you be always looking at these things, why don't you get a C right, right away? And it is the difference of the squares, because A is the biggest one, right? So be radical 8 or 2 radical 2. So now what do we need? Center, right? Center, because it's a shifted ellipse. Center is located at HK. So H and K are the numbers that you subtract from X. That means H is 2, but K is not 1, but negative 1. Okay, so then now always ask yourself, where is going to be ellipse, hyperbola, parabola? Is this ellipse a horizontal stretched ellipse or a vertical stretched ellipse? Horizontal, that means you should look at not C, right? So one of those guys, right, from A, B, and D. Well, the center is in the 4th quadrant, right? Positive X, negative Y. That means, that's good enough to pick letter D, right? Now, but what if you need to do more than that? Let's say you have to identify from those options where the foci, where the vertices are. It's very important to know where the center it is and also in which way it has been stretched. So now we're looking at a sketch, right? So we know from the standard form it's the horizontally stretched ellipse. That means the foci, the vertices, they're all going to line up with the center on a horizontal line, right? So if I were you, I will start from the center. Before I write down the coordinates for either vertices or foci. Vertices. All right, so the center is at 2, -1, right? Now, starting from the center, going left and right by C units, you're going to see the foci. And the reason why I'm going left and right is it's a horizontal stretch ellipse. So plus or minus 2 radical 2. Okay? When it comes to vertices, the same thing, right? But instead of going with, plus or minus C, you're going to go with plus or minus A. Okay? And that's it, right? There's nothing else you have to know about the ellipse. Okay? And it could be done within a minute or two. You just have to go through the logic and make sure that, you don't hesitate at any, level. Okay? Now, like I said, ellipse is supposed to be more intuitive. Usually people don't have issues with that. And therefore, 43, if I have time, I'll put the work there, maybe later today or tomorrow. But I don't think you need anything more than just 41, right? Because it's just the same thing, right? Instead of getting the graph, find out what the foci are. Now let's take a look at 45. Now the hyperbola. So the only non-intuitive part for hyperbola is the standard form, right? Because you have a minus sign, and therefore the A's and B's are, a bit different than what you normally think. But anyway, so you're still going to rewrite it. Make sure that you're able to find what A's and B's are. So y squared over 9. So you see that I'm divided out of 9 minus 9 x plus 2 squared over 9 equals 1. And that turns into y plus 2 squared over 9 plus x plus 2 minus x plus 2 squared equals 1. So now the way you tell which number is it going to be, so let me put the 1 here so that you can see it better. Is it 901 that goes into the a squared? It is not always the bigger number, but it is always the number that goes with the positive quadratic term. Right, so that's the catch for the hyperbola. So a is going to be the square root of 9. That turns into 3. And b is the square root of 1, which is still 1. Oops. It's fine to see. You probably don't need it at all. In this case, it will be 9 minus 1. Oh, still radical 8. Well, let me put the, see, I almost made the same mistake. C is the largest number, right, among all three, remember? So now you're actually getting the sum of the squares of a and b, not a squared minus b squared, but a squared plus b squared, and that'll be radical 10. So now what else do we need? If you remember what we did in 41, we looked at the center, right, of the ellipse. So that was almost, good enough. Well, plus we know the orientation, right, that ellipse was a horizontally stretched. So what about this one? Is this a vertically opening or a horizontally opening hyperbola? Vertically opening, since it has a positive, quadratic term in a y, right? So it's a vertical, that means get about b. And now you're looking at, it's hard to see, right? The center of this guy is in a third quadrant, somewhere closer to the x-axis. This guy is in a second quadrant, and this is still in a fourth quadrant. But it turns out that's all you need, right? Where's the center? Center h comma k. In this case, it will be 2, negative 2 in negative 2. Right? So obviously in the third quadrant, so C is out, right? When it comes to A and B, I can see that, that center is 2 units to the x, 2 units to the y in the third quadrant, therefore has to be D. Okay. But of course, if you have to get everything, right, foci, vertices, even including the asymptotes. But let's first get the vertices and foci, figured out. So vertices, foci, they are still lined up with the center, right? And depending on whether it's going to be a horizontal or vertical open hyperbola. Since it's a vertical hyperbola, everything's going to line up on a vertical line. Therefore, you should start from the center, -2, comma -2. But now we're going to go up and down by A units to see the vertex, up and down by C units to see the foci, right? So as you're going vertically, there's no change in the X coordinate. But the Y coordinate will be modified, right? So vertices going up and down by 3 for foci, so going up and down by radical 10. Okay, let me put them a little bit closer. All right, make sense? All right, now the final challenge. What about the asymptotes? Oh, so well, you guys can't remember that? But I couldn't do it, Yeah, because I always gonna hesitate because it's A or B, B or A. Well, I kind of see, why sometimes, I do that, or I shouldn't be the only one that has this kind of concern. It's like I cannot afford making mistakes. It's like you asking me, in office hour, Dr. Wang, you think it's A or B or B or A? Wait a second. All right, so let me get this right. I cannot get it wrong, but I shouldn't say that, you don't care, but at least that is going to cause you less, right, in whatever way to make a little mistake. But it shouldn't be like that anytime soon, right? You should worry about, not getting the right answer, especially for something that's for sure. Therefore, I want to find a error-proof way to always get it, right? And I can also make it more efficient. So I suggest that you do some algebra, which is very doable. Just go get your standard form if you like, or you can even go with the non-standard form. So let's say if just want to be consistent as what I did in class, I'm going to grab that standard form, y plus 2 square, over 9. Minus x plus 2 square equals 1, right? Let me put down the steps. And again, you see it in the recording so then you can follow if you want to do something like that. Step 1 is separate the variables. Oops. The variables. Here we have y squared, x squared, right? But don't expand it. Just do this guy, x plus 2 squared to the right hand side. So y plus 2 square over 9 equals x plus 2 square plus 1. All right, step number 2. Drop non-leading, or in this case, it's just the constant term. It's just that one. Right, oh, that's a term. All right, so you're looking at y plus 2 over 9 equals x plus 2 squared. Step number 3. So isolate the y minus k squared. Okay, so in this case, it will be my y plus 2 square. So it'll be y plus 2 square equals 9x plus 2 square, right? The last step, take square root on both sides. And don't forget the plus or minus. All right, so that turns that equation into y plus 2 equals plus or minus 3x plus 2, right? And this is known as the point slope form. All right, so we have two slopes, right? One for each asymptote. But the point that the line has to go through will be at -2, -2. Not surprisingly, it is the center of the ellipse. Sorry, the hyperbola. All right. But the reason why I'm putting down that many steps is not asking you to do that, like writing it down in a test. You should go through the logic in your head, because I think that just by inspection, you should see right away, like, we should be getting, right, for the y squared term. So that way, just by doing one step of algebra to make sure that it's going to be 1 over 9 or 9 over 1, right? Square root will be 3 or 1/3. Because like I said, it's very hard for me to tell right away. It's going to be either A or B, A or B or B or A. Okay. Now, this is the hyperbola, right? And obviously, you see that a question like that, asking for everything. But if you do that, sketching and whatever, right? So you should be able to. Yeah, Zach. Oh, sorry, forgot about. Yeah, thanks. So yeah, go ahead and take a break. Yeah, I was Go ahead. Yeah, so come back in 10 minutes. Ten minutes countdown. Hey, yeah.
Did you want me to stay after school and go to your class and talk to you?
I'm there. So yeah, if you want, like I said, look into the two tests, right? And whatever question you got wrong, let's make sure that you're able to get them right in a better way, right? Yeah. So yeah, come to me. I probably have a few students maybe come in to take the quiz, because somehow the technology doesn't work in the morning. Yeah. But yeah, so just let me know when you're there. Then I'll come and talk to you and whatever.
Because we said 3:30. Do you want me to come in today?
So let me see. Today, I need to go by 4-ish, like a 4:10. Yeah. So in your case, now if you're gonna be there a bit earlier, let me know. And because in your case, I just have to talk to you real quick, right? I think that those people are just there taking a break. If you wanna get there at 3, that's fine. Oh, that's good. Hey, Akeem, what's up? Okay. Hmm? Yeah. Say it again. Were the scores for the first class good? It was like close to 70%. But think about this, since it's extra credits, how motivated you think your students are? The 4. Because now they're looking at, as many points they can get as, as possible, but it won't hurt if you miss one or two questions. Right. Again, which units is it on? 4.1 to 4.3.
Okay, we did that.
Oh yeah, that's why I'm saying that, nothing beyond question 35.
Yeah.
Okay. No, and then she said, do you know what the market or something like that? Oh my God. And then they stopped me and they started talking to each other.
Tumblr.
Why?
You know something too? Every season they have one artist and they quote their song. I think like they said seasons all that. Like what's that show like? Oh, she worked at the pyramid. The first season they quoted all of it. So but they put some either. Or you guys like the time. That is the grand problem. I guess you get positive when you're looking at it. And also, no, we're gonna gather me some on it, plus else. We're gonna gather me some.
Okay. So we want to get this. Who was that? Yeah. No. This is
Yep. Well, he's actually doing a baseball. Yeah. Well, are you gonna still be there in the summer? On what days?
I'm normally working Saturdays.
Saturday. Okay. Yeah. Exactly like the time window you'll be there. All right. Let me see.
They're open like very specific hours, so I don't know what you transfer.
Oh yeah, because Saturday has like a maybe shorter hours. Okay. Yeah, you know what? If it works out, I'll just because he's asking me like, you still there? You still in my class or whatever. Yeah, I mean that you let me know. You thought, yeah. Because so what's more important is the reason why I call it program is walking around, whatever. Most of your time that you walk around, like you're watching other kids doing some other stuff. Right? Is it like that? Things get harder, and you like stay there and work for like an hour, right?
You were starting with like whatever you want.
Yeah. That's first thing. Then once we start, walk, with each other, right? I think that. Yeah, he's gonna be there for again. He's gonna go.
Yeah. I just put it in.
Maybe in the fall, it's not having. Alright, so every time we start Saturday. Okay.
Hopefully I get more hours over the summer.
Say that if you can squeeze out 1 hour.
Last day. Yeah,
Right,
the lawyer. Her. Like she's still. She's educated. No, don't say like this. She's not. She's actually. Meaning like, so you guys are straight.
You said
Marriage, she tried to wait for marriage. She said she's straight.
Yeah. Yeah.
All of chapter 10 and then 4-1, right?
No, just 4-1. 4-1 to 4-3.
There's 4 questions are 4-1 to 4-3.
Yeah. But you see, 4-3 is so for 4-1 to 4-3 is just everything on this packet up to 35.
This is like a couple of.
Yeah.
Yeah.
Yeah, and you're probably gonna get the gist, what those questions might be like from a quiz, because again, there happen to be 4 questions.
Okay.
All right. Yeah.
Yo, she just like practice in the mirror. And like she has like even if you watch it, still gives you this. I'm gonna start right. You remember when we was in that? We was in.
Go around. Go ahead.
You remember when we was in that? I like this.
Maybe that was my first impression of you.
Yo, I'm so mad at the beta guy.
Daniel's so funny. The Daniel was very big.
She's so.
All right. Let's see. You need 10 minutes. Alarm at 2:35. All right, guys. Already set alarm for 2:35. So when it's about that time, I'm gonna try to get started with the quiz. So you have at least 10 minutes to work on it. Okay. Let's get started with all right, testing. All right, so as you can see, that 47 should be trivial now, right? If you see from the standard form, you do have to rewrite the equation to get a standard form and find out where the center is, right? And go from there, finding the vertices and foci. But of course, you see those options and you see that from a graph or competitive graph, these options are actually easier for you to eliminate, right? So first off, you should see from the centers, right? It will be -2, -2. That means C is out. Okay, so now let's see what are the differences between or among A, B, and C. Well, I see that they all have different vertices, right? Now, let me see if you guys can tell if that's a vertical or a horizontal opening hyperbola before rewriting it. Or would you need to rewrite it to be able to see? Vertical because of the y terms, right? That's positive. Okay, so it's a vertical. That means a hyperbola is going to go like this, right? That means the vertices and foci are going to line up on a vertical line. What the center is, it's -2, -2. So you go up and down to get the vertices. That you should be looking at the same exact x coordinate, right? But going up and down to reach, different y coordinates. Hey, do you see that letter B and D has the wrong x coordinate? Because they are not lined up with the center. That means it has to be A. Should you do that every time? You could think about using that as a sanity check at the end, right? So if you're now very quick doing all of that, right, sketching, find out the center and do the A units, the C units, right, find out the foci and vertices, great, right? Move on to the next question. But if you have time at the end of the test, come back to it and ask yourself, if I pick A, does it make sense? Or the vertices and foci do line up the way I want them, okay? And also, this is not just about the test tomorrow, right? The final as well. Now, let's move on to the last topic in chapter 10, right? 10.3. But don't get me wrong, there are so many other things that the test and final could check. But I think that only just by looking at those kind of problems, you're able to put all the skills, right, techniques that you need to master all at once, right? But again, it's the thinking process behind understanding the graph, matching them with the graph, the equation, right? That's going to make sure that you do fine in the test or final. Now, I think that we did something very similar to 49 either in the actual like a class packet. It's a parabola, right? So of course, you see it's already in a standard form. So you could identify the vertex by looking at the h and the k. Again, they are the numbers that you subtract from an x and a y. Therefore, it will be -2 and -1. Oops. So that's in the third quadrant, right? So I hope that you see right away C is wrong. And the vertex are here, here, and here. Okay. Now what else? Well, it's a horizontal opening parabola, right? I don't know if you realize, since it's the y gets the square, not the x. So the linear term, right? The x tells us that it opens in the x direction. But with 4p, which is that constant in front of the linear factor of x, right? So -6. So you can tell that p has to be -3/2. A negative p tells you it opens to the left, right? First of all, it's horizontal parabola, then it opens to the left due to the negative p. So now these out. So when it comes to the a and the b, as you can tell that it opens either super wide, like in b, or narrower in a. So there are two ways you can typically look into how wide or narrow it opens. If you want to go with the book, they do something called the lattice rectum. I don't know how to wait. The 10 point. I want to make sure that I have no misspelling. Okay, lattice rectum. Lattice. So that's a segment which has a measure to be absolute variable for p. So in this case, that you could have realized it's +6, right? Since 4p is -6. So that tells you if you were to find the foci, okay, which should be, in this case, a little bit to the left of the vertex, right? Think about why we call it focus, right? It asks you, or it asks the graph to focus on that direction. So if the graph opens to the left, the focus has to be to the left of the vertex, right? So you can see that, well, obviously here, well, of course, I don't know where the foci is, but it seems that this is way beyond 6 units, okay? Now, again, if you want to know the official definition, letter rectum is a segment that is going through the focus and perpendicular to the axis of symmetry. Think about that the parabola is like a bow, and the letter rectum is the strain. So you see how long the strain is, right? So then the bow is either fully stretched and getting super narrow, or you just barely stretch it. Anyway, so I think that in this case, I'll go with letter A, since it doesn't open that wide, right? Because you have only 6 units. All right, so that's the parabola, right? So I don't know if that was the case that let people, a few people missing, questions yesterday. Oh, sorry, my bad. I keep thinking about the quiz. No, because there wasn't any question about parabola yesterday. Anyway, now, again, as you know, there could be questions either having you to look at the graph, right? Or just state, right? These things. And I guess that is the directrix that probably brought us a few of you guys. Nothing hard about directrix. It's just weird. So let's quickly do that. Now, first off, it is again a horizontal opening parabola with 4p to be -20. So then p is -5, right? So it opens to the left. So the vertex is again the number subtracting from x, so it'll be 3, right? Subtracting from the y, -1. And I guess that we should be able to look at just A and B. Now the focus, well, they're very different, right? Therefore, just take a look at the focus. It's a horizontal parabola, and it opens to the left. That means the focus has to be on the left side of the vertex, right? So as you can see, the B has the focus to the right of the vertex, right? Oh, someone picked the B? So it should be A. Now, I mean, you see that you probably don't even need to look into the directrix. If you want, let's see if it makes sense. Now, of course, all the directrix are a vertical line, right? Because it's x equal to a number. But where should the directrix be located? Focus is on the same side, right? When the parabola opens towards the focus, right? So in this case, it's a leftward opening parabola. That means the focus is going to be on the left side of the vertex. But the direction is going to be on the opposite side of the vertex. If the focus is on the left, the direction has to be on the right side of the vertex. The vertex is at 3, right? When it comes to x. On the right side of it, x has to be 8. Well, in this case, right, not -2. Because -2 is on the left side. So either way, you should remind yourself if you can ever quickly get into maybe some options by eliminating a third one, do that, right? Or if you feel like using that as a sanity check, that's also a good idea. All right, so now those are half the questions about chapter 10 in my final review packet. But like I said, I urge everyone to try the even number questions from 41 to 52, right? Only the even ones because I did most of the odd number questions. Now we have probably a couple more minutes. Let me try a few problems for chapter 3. All right, so because now I hope that since there are only that many questions we can use in a final, right, to check almost everything throughout the whole semester, there are certain things that we'll take more seriously than some other stuff. So just by looking at those questions in the final review packet, so you should actually feel more confident about the final, since now you're looking at something I'm sure that everyone is super good at, right, when it comes to finding the zeros, right, and multiplicities. Not to mention that the even odd multiplicities tells you how the graph should, react to those zeros. Now, but I do want to point out sometimes people might, so I'm sure that this is probably not a big deal, right? So you do have a zero at -3/2 and a zero at 5. So it means B, the D are out, right? So let's see the 5. Okay, so when it comes to multiplicity, the -3/2 as multiplicity 1. If it's odd, it will cross the x-axis, right? And therefore C has to be the correct one, right? Now what about um 3x let me change that into x squared plus 3/2. And there are a few things that I could have asked. The first thing is, what is the degree of a polynomial like that? How do you get 4? So 3 times x squared plus 3/2, then x minus 5 to the third, degree 5. Okay, so looking at every single factor, the degrees add up. This is degree 2, that's degree 5, right? Now, how many zeros are there? And what are they? So everyone agree that there will be a 0 at 5. But are we getting zeros at -3/2 anymore? No. Because if you were to set x squared plus 3/2 to 0, and there's no real solution, because x squared is -3/2, right? Unless x is imaginary, this is not going to work. So you know that there could be some little, subtlety here when it comes to the sign of it. Because if I were to make this sign negative, then it will be different, right? Or try that. All right, so that's f of x. Let's say g of x, 3x squared minus 3/2, x minus 5. Oops. Okay, so now what about the zeros? What are they? Well, I'll write it down, at least one of them, right? X is 5. Are there any more zeros? There are more than that, right? So if you're thinking about, okay, can I get a 0 out of that factor, x squared minus 3/2? You set it to 0 and solve for the x, right? And it's x squared equals 3/2, right? And you do get 2 more zeros, right? Plus or minus. Yeah, Zach. Because now I'm looking at the g of x. Now, the last question I have about, the g of x, what's the multiplicity of those zeros? Let's say the 5. Multiplicity 3, obviously, right? But what about those 2 zeros? Plus or minus radical 3/2. Some say 1? Yes, it's 1. Now, the confusing part is people thought, oh, you got that 0 or 2 zeros from a quadratic factor, right? A degree 2, but you do realize these 2 zeros are different, right? So now you have to understand, what do I mean by multiplicity? Multiple, right? So how many multiple times that 0 appears? Therefore, yes, you do get a quadratic, but it is because you have a quadratic factor, that means you have 2 zeros. They're different. They didn't repeat themselves, so you get multiplicity 1 for each. Okay. But again, most likely you're getting something at this level, the same as the question number 1, right? You can probably see from question number 2. Oops, sorry, I didn't have the question 2, but you look it up on the final review packet. I have 2 more minutes. You know what? I would like to try this problem real quick, or you try it to see if you still remember. If you don't, that means this is something you have to remember. What's the relation between the number of turning points and the whatever you think from the polynomial? Like degree minus 1. Thank you. So then what's the degree of this guy? I'm glad I asked you guys this, at this moment. It's 3. First off, it is the leading term, right? And somehow they decide to put the leading term in the second one, right? Don't get, don't get confused, right? It is telling you degree 3. Now, the reason why people are probably thinking about degree 5 is degree add up, right? But there is a catch here. Look at the difference between these 2 polynomials. The one I have over here, I have a degree 1 from this guy, and from degree 3 from that guy, but x plus 3/2 is a factor. It's a binomial factor, right? X minus 5 is also a binomial factor. But what I mean by factor, the part in an expression that gets multiplied together. If you're looking at factors, their degrees add up, but not the terms. You see that here, x squared is a term, right? 8 times x to the third is a term. How do you know it's a factor or a term? Terms are the parts in a polynomial that get separated by addition or subtraction. It means these 2 things add up, they're terms, then you're going to go with the leading term, and whatever power the leading term has is the degree of the polynomial. Okay? But in this case, degree 3, therefore, at most, you get 2 turning points. Okay? It's as simple as you remember that fact. Anyway, so now